Okay, welcome everyone. This is our webinar from Altinity called Fun with ClickHouse Windows Functions. My name is Robert Hodges, and I'll be presenting today with my colleague Vitaliy Zakaznikov. We both work for Altinity. Before we dive into the details, I'd just like to share a little bit of information that will help you enjoy this more. First of all, as you probably just heard, the webinar is being recorded. We'll post a link afterwards, and you'll be able to look at it and view it again at your leisure, share it with your friends. We will also be posting the slides. In fact, the slides are available now. I'm going to repost that link in the chat. So you should see this come up. If somebody can confirm in the chat that they can download the slides, that'd be very helpful. I want to make sure the privileges are set right. We also have question and answer. There should be abundant time to answer them. If you have questions, just feel free to post them into the Q&A box. It's available on in the Zoom menu, and we will answer the questions in passing if they're relevant, or we will go ahead and get them at the end. We should have a good chunk of time to answer questions. Okay, with that, I think we've cleared out the housekeeping. I'd like to go ahead and dive in. So a little bit more about our bios and Altinity. So I'm CEO of Altinity, but I've been working on databases since 1983. ClickHouse is database number 20. It's definitely in my top two. The other one was Sybase, which I just loved when I worked there. I have with me today Vitaliy Zakaznikov, who's the QA manager of Altinity. He has over 13 years of testing hardware and software. He wrote the Test Flows open source framework, which we use for all of our functional testing of ClickHouse as well as other products. There are many, many Test Flows tests in the GitHub for ClickHouse itself. A little bit about Altinity. We are an enterprise provider for ClickHouse. We do everything from offer training to offer 24/7 services, to put engineer features into ClickHouse itself as well as other products. And finally, we run ClickHouse in the cloud. That's altinity.cloud. So if you don't want to run it yourself, you come to us and we run it in the Amazon cloud for you. We will soon be offering GCP. Beyond that, relevant for this talk, we're a major committer and community sponsor in ClickHouse, particularly in the United States and European markets. So that's us. Let's dive in. So just as a level set, I would just like to briefly introduce ClickHouse in case there's somebody on this call that's new to it. ClickHouse is a really great SQL data warehouse. It's actually the first open source SQL data warehouse which can compete with the big kids. And let me just give you a few of the properties. So you can think about ClickHouse, excuse me, as being kind of like the marriage between the best parts of MySQL and the best parts of a proprietary data warehouse like Vertica or Redshift or Snowflake. So first of all, from the MySQL side, it understands SQL, of course, as any self-respecting database does. It runs everywhere, so it's extremely portable. Basically, anywhere Linux runs, ClickHouse can run. It does also run on their cross builds onto things like Mac OS X. Those are not as heavily used, but are also supported. It is open source. So in the case of MySQL, of course, it was GPL v2. ClickHouse is Apache 2.0, so very flexible license that you can do anything with. On the data warehouse side, from that heritage, we have a shared nothing architecture. This is very similar to the original vertical architecture, so a bunch of nodes with attached storage connected over a network. We are actually doing quite a bit of work in the community to decouple compute and storage, but that's another topic, and hopefully we'll do a webinar soon to talk more about that. Like most data warehouses, we store data in columns with very high compression. So you get enormous storage efficiency, and believe it or not, you can actually reduce the amount of data that you're storing by a factor of up to 1,000, and then beyond, there are ways to reduce it beyond that through pre-aggregation. Very efficient parallel excuse me, and vectorized execution. So the ability to split these columns up, you treat them as arrays, load them into the CPU. They're cache aligned, so you tend to get relatively good usage of onboard caches like L1, L2, L3. You can also use SIMD instructions, so single instruction, multiple data, that allow you to just race through these columns when you're doing things like sums or multiplication, things like that. ClickHouse runs great on a laptop. It also scales to clusters that include tens of petabytes, excuse me. The largest clusters are in the contain hundreds of nodes, and there are now many of those worldwide. And then the final thing that everybody notices about ClickHouse is it's super fast. It's optimized for speed at every level, starting with some of the things that I mentioned, but there are many. The list of features that help with performance are so long that you can't put them on even a single slide, even with small print. We won't talk too much about performance today, but it's something that strikes people when they first start using it. Now, one thing that I want to introduce here is that in these talks, we're increasingly doing these as particularly as we do education and talks like these. Every example you'll see in this talk, you can actually go execute on ClickHouse right now. If you want to sing along, if you will, you can go ahead and actually log in to the altinity.cloud public endpoint. I show the link here for logging in on for logging in using the web UI that's actually exposed. Password user is demo, password is demo. So you can log in. If you have ClickHouse client, feel free to log in as well. The link is shown below. I'm going to, since we had a number of people just join us, I'm going to go ahead and republish the link to the slides so that you don't have to remember these. You can just hit the link and connect or do copy and paste. Okay, so we won't do too many demos. It's mostly going to be text, but as I say, you can play around with these things and you should see them working just as they work for us. Okay, so now what I'd like to do is kind of dig into what window functions actually are. So not everybody, particularly if you're a ClickHouse user, you probably haven't used them very much because prior to 21.3, they didn't exist. So that was earlier this year where they first became available. And development led by Alexander Kuzmenkov has been going on for the last, well, actually for a prolonged period of time, but we're continuing to work on them, test them, so on and so forth. So what are they? Well, I think to understand Windows functions, it's very helpful to just start with SQL without window functions and understand what it can do. This is a simple query. And by the way, we're going to look at a lot of code in this webinar so that you can understand exactly how this works in SQL. But this is using one of our favorite data sets. It's called the airline on-time data set. It tracks flights in the United States by commercial aircraft. And what this is looking for is it's counting up the number of flights per day and the number of canceled flights per day for January 2019. So very straightforward query, and this is probably, this type of query for anybody who uses ClickHouse is something that you probably do all the time. So it has your group by, it has your order by, nice aggregates, and relatively simple to understand. What I'd like to do is dig into the model behind this, because in some sense, when you build a query like that, you can think of this as representing something very similar to what used to be called an OLAP cube, which is basically, you can think of the data that you're selecting as some of the columns being what we call dimensions. They are things that describe the record. And then there are other things which are metrics or measurements on the data. So for example, in that query, one of the dimensions was flight date. We're grouping by flight date. Another dimension that we're using is whether something is canceled or not. So I consider that a dimension. But what we're going to do is go ahead and actually compute metrics on that. So in one case, we just do a count of the number of records per day. And in another case, we're doing a sum on this canceled field, which I guess you really could argue is a measure then. So, but the point is that you get a cell here which is the intersection of canceled and sort of reflects this value. And what we're doing is basically presenting the results from reading that cell. So all the other dimensions are ignored, and we just focus on these two particular, these things that are specifically interesting to us. This is a great model, and it helps you to understand a lot of what goes on in SQL, particularly if you're using BI tools like Superset or a Tableau or something like that, which actually have this model essentially embedded in the way that they operate. There is a problem, though, which is because we have the dimensions and then we take the measures of things that belong in the cells, there are certain types of questions that are difficult to answer, in fact, impossible to answer just using a simple SQL query. So for example, what if we wanted to not only take those measurements, but also rank particular days of the month based on the number of canceled flights? Like, what day of the month is number one in canceled flights? Another thing that we might do is, as we're looking at the rows for each day, we might like to sum the number of canceled flights that have happened up to that point in the month. A final thing, which is very, very common when you're looking at time series, is to compute a trailing average. For example, a trailing 7-day average of cancellations. You can't do this in ordinary SQL. You basically have to pull the data out and put it in an application and do some, for example, stick it in pandas and do some additional processing to get this to happen. So there is a feature in SQL, though, that allows you to do that, and that's window functions. And we'll show how they work concretely, but the first thing we need to do is in ClickHouse, we need to turn them on. So in ClickHouse, window functions are still considered experimental. If you're a ClickHouse user, you're well aware of the fact that we tend to put stuff in. There'll be some period of time where there's a switch that's necessary to pull it on or to turn it on, because we don't consider it really completely stable, and it's only for people who are ready to use it. So you can do that in a session by setting this flag, allow experimental window functions, or you can actually turn it on inside user profiles. And for example, in the Altinity.cloud server that we use or servers that we use to generate these examples, that's actually how we turned it on. So this means that anybody who has that profile can use window functions. So if you turn them on, you can then now add something new to your queries. So what we're trying to do here is taking the last example to do a rolling average of 7 days. And we can now add some additional syntax where we're looking at this thing called average of the number of canceled flights. And then we have this clause called over, which defines a window. And then there's an expression here, which basically says, hey, look at the data in the current row, and then for the 6 preceding rows. And because the data is time ordered, it will then basically give you 7 days, and we take the average. So that allows us to layer some additional processing on here that actually takes this aggregate that we commuted, the sum of the aggregate that we computed, and actually begin to look not just in the cell that we're processing for this row, but to begin to look at cells before and after. This is basically what window functions do. They extend the model so that you can now consider the things that relate to other cells in the cube. And we get numbers. So there they are. This just shows, and in fact, this gives you an example of looking down the data a little bit. Here's what the rolling average actually looks like. You can see that the rolling average is computed across month boundaries and any other time boundaries within the data set. So that's a window function. We're going to show a lot more examples of these, but this is basically how it's used. Now, just looking at it, again, conceptually, here's what's happening. So we take the average and we're referring to one of the aggregate values that we previously calculated. In this case, it's the daily canceled calls, daily canceled flights. That was created by just a sum function on values that were being grouped by flight date. And then, as I mentioned before, we then compute this. We have a frame, which Vitaliy will explain this syntax in much more detail, where we look at the current row and the 6 preceding, and then when we're done, the result is just another output column. So this is a pretty major extension to SQL that enlarges the model and allows you to do some interesting things on top of aggregate data. And that's a big reason why it has been a huge feature request, possibly, maybe not necessarily the #1 feature request, but very, very high up the list for a number of years. So at this point, I'm going to turn it over to Vitaliy, who's actually going to dig into the detailed syntax of window functions and show you how they work in gory detail. So Vitaliy, go ahead. I'll move to the first slide for you.
All right. Hi, everyone. So my name is Vitaliy Zakaznikov. Thank you, Robert. So for those of you who have experience working with window functions from either MySQL and PostgreSQL, this information might be redundant or can be a refresher. But for most common users with ClickHouse that never played around with window functions, yeah, we hope this information will be very useful. So Robert showed some introduction of how a window function can help you, right? Basically, process, view your data in a different way, right? It enables SQL to do something that it couldn't do before, right? It was easy to do, right? So let's look around, and dive into what window function, the details, right? And the first thing that, usually it helps, at least for myself, was, help me to understand is actually trying to visualize, right? What's going on with this window function? Well, I think, when you try to understand new concept, it's, you go by the title, window and function, right? So there's something to do with windows and something to do with functions, right? So let's try. This picture actually shows what the window part looks like. That to understand window functions, you have to visualize, right? That we have some kind of a window, right? So a window can look at all the rows in your results or just a chunk of them. So you can partition your results into windows. The next thing that you see that, when a window function is computed, a current rows is what starts moving or sliding. Specifically, you have a frame within the window and there's a current row there, and you build a frame, and the frame can only be a current row or something, a previous and number of rows before current row, some rows after the current row, but that would define your frame. And that thing will be sliding inside your window. And then you would apply a function over it. So this should give a general idea of how one could visualize the process of how ClickHouse is doing computation. So the main part is that, there's a current row and the computation is done for current row in your result set. And we can go to the next slide. Why would we care, right? Why would we know about this, the details? Well, the answer is simple. The behavior is not very obvious. So let's look at the very simple example. Robert showed an example where you deal with a real data set, right? And if you compose a query, right, using SQL that uses window function and you get a result, sometimes not obvious. Is it doing the right thing? Are you getting the expected result, right? Is the computation right? So in this case, when we talk about introducing the concepts, we're going to be playing around. We have this simple syntactic examples. In this case, we just querying a table function numbers, and we get, we just have numbers there from 1 to 5. Very easy example, easy to understand what's our table looks like. Just not one column has 1 to 5, right? And then we have a simple window function, right? We have a sum of numbers over an empty, braces, right? And so you run that query, it returns you something, right? And then you have to understand, what did it do, right? How did I compute those results, right? In this case, we see that for each row, right? For each, we got the same result, 15, right? And then one had to understand, like, why are we getting that answer, right? So that's the primary reason why we want to explain, like, the details behind the window functions. So in this particular example, there's 3 things going on. The first thing, our over clause is empty. So that means that only one window exists, and that window includes all the rows in your result. Second part is that we have no order by clause defined for our window. So it means all rows are the peers of the current rows. And that concept of peers of the current row is very interesting, right? And we'll go into details in the further slides. And the third point is that we didn't specify any range, a frame, right? So there's a default frame, and what is the range for that frame, right? So the default is that we use a range frame, and our frame extent is between unbounded preceding and the current row. So you have to know and understand those three things to understand the result. So in this case, because we're just summing all the numbers, because for each row, we're looking at all of them at the same time, we're summing all of them, and the result of summing all these rows will be 15. And for each row, we're doing the same thing. That's why we have a result of 15 for each. So let's go to the next slide. So we try to talk, try to visualize the window. Now, what about the function part? Well, as you've seen in the examples, a window function can be, for example, the simplest is any aggregate function. So any aggregate function can be applied over the window. And this function can be like simple function, aggregate function like min, max, sum, average, etc. And there's a simple example where we can compute the min number, for example. Then there's also special function they called window native functions. These functions will work only with Windows. And this function includes, for example, row number, first value, last value, rank, dense rank, leading frame, lagging frame. But for now, you just have to be aware that a window function can be either any aggregate function or most of the aggregate function or a specific window function. Let's look into how these windows are being defined and what is the what constitute what is it made out of. So if we go to the first part that you've seen, and if you're not familiar with the window function, you see there's such a thing as an over clause. So first you have a function, it takes like a column, right? And then you have an over clause. And you have those three basic scenarios there. The over clause can be empty, can have a window specification inside the parentheses, or can have can refer to what we call a named window. So if the over clause is empty, it means it's the case where we have only one partition, and that partition includes all the rows in your result set. If you have a window specification, that specification will define the windows, one or more partitions. And if you have a named window, it's kind of a shortcut. For example, if you're working with different windows, then you don't want to repeat your window specification many times, right? You can just define it once and use it for in more than one over clause. So let's see what a window specification can look like, because to define a named window or just you inline define in over clause window specification, you need to know what the parts that make up that window specification. So next slide. So so here's what's the basic parts that make up window specification. Just three parts. There's a partition by clause that defines the window partition. There's an order by clause that orders rows within that frame, and a frame clause that actually defines the frame within a window partition. And for the frame clauses, there are two types. And in MySQL and Postgres, there are actually more types, but currently ClickHouse supports only two. And these are the row frame and the range frame. So next slide, Robert. So what's the difference, right? When you have a row frame, it defines a frame with a range in terms of relationship to the current row number. So and that relationship now is defined in terms of rows. So you can say it's like rows one preceding, means it's one row preceding the current row. The relationship can be also defined in terms of a range. For example, and that relationship is to the value of the current row. So you would say, for example, one preceding, in this case, it will be one minus the value of the current row. So that's the basic difference between row frame and range frame. And when you define a window, you can specify, okay, my frame will be, is it going to be in terms of rows or in terms of a range? Range frames are special, and when you deal with the range frames, there's a concept of what are called current row pairs. So, and the next slide. And the current row pairs, what are they? Without understanding current row pairs, it's really hard to work with these range frames. So let's look at a specific example. We have two examples. One doesn't have order by clause when in your window definition, right? And the other one has order by clause. What is the difference? If you look at the simple queries that we have here, as you can see, in first case, we have, again, the sum column is, again, the same for each row. Because in this case, all rows are considered to be the peers of a current row. And what is a peer of a current row? Is, as we have on the slide, it's all rows that fall into the same sort bucket. So if you're not sorting your rows, all rows in a frame are the peers. If you do have an order by clause, then that is not the case. So if you look at the result of this query, you see that for each row, right, current row, the sum is different, right? And for example, when you have twos, right, there's a two number twos we have, right? So for that row, the peers will be 2, 2, and 2, right? Plus the previous row, so it will be 5, and so on. So knowing what that concept of current row peers, right, it's important when you use range frames. So you just have to be aware that, you know, whatever rows fall in the same sort bucket are considered to be the peers of that current row. Then what about, you know, once you picked your frame, either rows and or range frames, you know, you can define the extent of that frame, basically the boundaries of that frame. So there's two ways to define these boundaries, either using the start extent or between clause. So in reality, if you only specify the start for your frame, you know, the end will be implicit. What is that implicit end? Is the current row. So and we see the example. So if you write a query where you have just you know, order by number, rows 1 preceding, so 1 preceding, that will be the start of your frame. What will be the end? And actually, if you type that query in the ClickHouse client, right, the query that ClickHouse will actually be executed is the one that's right below it. You will see that actually it converted your query into using between, and the between clause is explicit. It has a start and the end. So for the start, it will be 1 preceding, just like as you specified, and the end of that frame will be the current row. On the opposite side, if you do explicitly use the between clause, right, then, and you specify your start and end, then there's no transformation, right? ClickHouse will take it, and your frame will be, the frame range will be as you specified. So in this case, you specify, you know, between 1 preceding and 1 following. That's what you get exactly. So you just have to be aware. If you don't specify, you know, explicitly start and end, then the end is implicit and it's a current row. So let's see for these frames, start and ends, you know, what can these values be? And there's just 5 of them, and they're standard. You know, there's a current row, unbounded preceding, unbounded following, expression preceding, and expression following. And these, some of them behave, as you can see from the slide, you know, a little bit differently based on the type of frame you have. Either you're going to have rows or range. For the current row, it's the same in both cases. For the unbounded preceding, it's also the same, because if you have specified that your start is unbounded preceding, then your all rows before the current row, right, will be part of your frame, right? Anything before current row will be in that frame, right? If you specify unbounded following, you're saying that everything, you know, from the current row following it also will be included in the frame. And if you want to have a granular control how far behind the current row or how far ahead from the current row, then you just specify expression, use expression preceding and expression following clauses or start extents. And that's kind of a rough introduction to how windows can be defined in ClickHouse. And the syntax is standard. So if you go to MySQL docs or Postgres SQL, you know, you will see a similar syntax, because ClickHouse picked a standard SQL syntax for defining windows, which is very nice and convenient. And I will pass it on to you, Robert. Thanks.
Great. Thanks, Vitaliy. So it wouldn't be complete. The discussion of window functions wouldn't be complete without looking under the covers and kind of understanding the plumbing, because it's actually significant and has potentially some performance impacts on your queries. So normally when ClickHouse processes a query, one of the things that gives ClickHouse its speed is the fact that it can parallelize the scan. So when in that first query that we looked at before I even introduced the window functions at all, what's happening is ClickHouse is actually going to break that query up. And if you're running locally, it's going to farm it out to all your CPU cores, pieces of the columns that you're looking at. And what we'll do is we'll race through the storage, reading things as fast as we can, and then doing what we call partial aggregation. So if we're doing a sum, we'll just sum up as much as we can find. And then what will happen is once the scan is done, those blocks get passed, well, they actually get passed incrementally back to a sequential step where we complete the aggregation and complete the sort. So these two left boxes, parallel scan and then a sequential aggregation, or we call a merge step, as well as a sort, that's what's going on under the covers with your query. Now, the window functions, because they're using, depending on the values of these aggregates, you can't compute the window functions until this first sequential step is completely done. What that means is, and then the window function itself is processed sequentially. So as a result, if you're doing something in the window function that would benefit by parallelization of that computation, it's not going to happen in ClickHouse. This is just the way that the pipelines work under the cover. This has a consequence which is worth thinking about, which is that if in fact this parallel scan is happening across a distributed table, so in other words, a distributed table engine creates an umbrella over a bunch of local tables. We farm out subqueries to each of the local tables, and then we pass the results back for final aggregation, sort, and to apply window functions. What's going to happen is your window function is going to be another thing that happens on that initiating node. And if you have an enormous amount of data passed back, or the window functions are very complicated, you potentially will have either resource problems like memory, or it'll just take longer because you don't get the benefits of parallelization. So it's something to think about in future. Now that window functions are stabilizing, we will be doing some performance testing on them. We do this a lot, and we'll be able to give more concrete advice on these functions. So anyway, that's basically what's going on under the covers. Let's then, since we've got did the deep dive into the details of window functions, I want to return back to the queries and on the airline or the on-time data set, and just give you some examples of using window functions on real data. So here's a simple example. Let's say that you wanted to print out the cumulative monthly cancellations, or cumulative cancellations by month. So you would take that query that we started with, and you're basically going to do a sum of the daily canceled. Your window is going to be partitioned, which means it's going to be broken up into sections, and we're basically going to basically process this, sort of build the cumulative sums by month, ordered by date. And you can see the results down here. You see the daily canceled flights in the third column. In the fourth column, you can see how they're adding, and they correctly, if you do the math, they correctly add up. So that's a simple example of a cumulative sum. You can do other kinds of cumulative aggregations if you want. Another one is to rank the cancellations by week. That was one of the examples we gave earlier. And here's what you're going to use is the window native rank function, which again is going to use a partition. So we're going to group the data when we're looking at computing the window function by weeks. The to start of week is going to normalize to the kind of similar to what we did in the previous query. We're going to normalize to the first day of the week, or the first moment in the week, and then we'll order it by the number of, in this case, by the number of daily canceled flights in descending order. So this trick now allows us to get what we call the weekly rank. And if we extended this, unfortunately the screen wasn't big enough, you would see that this week happened to have 5 days. It was an incomplete week, and you would see five different values. So that's again a pretty useful thing to get computed for you. Another thing is to do different kinds of ranks, and we'll get to this. Brings up an interesting issue, but what this shows you is you can actually have multiple windows operating in a single query. And this is where window functions really kind of shine, because it turns out that within ClickHouse, there are very few, I can't think of other ways you can do this easily. The fact is you can basically have the window functions looking at the data in different order with different partitions. In this case, what we're doing is getting the overall rank of the, here we were just counting flights as opposed to cancellations. And then we were also getting the rank by carrier. One thing that's interesting in this query is, this was done for January, the winner here is Hawaiian Airways. There's this airline, I don't know who these guys are. They don't have tail numbers, which is the flight, the identifier for the aircraft. But Hawaiian Air, if you ever fly on them, they do a huge number of yearly flights or flights per day. In fact, you can read off, they're doing about 12 flights per day for this airplane. So that's and you can then get the rank, with, of these numbers within the carrier and versus all carriers. So that's, again, a very handy calculation. You can also reuse window definitions using this window clause, which comes after the group by. And what that does is it's kind of like a common table expression. It means you just don't have to repeat yourself, or dry, as some people call it. We have a single definition of the window, and then we can just refer to it. I called my window 7-day, and then I just refer to it in the over clause when I'm actually doing the window function calculation. So that's handy and makes your queries a bit easier to read. Mine have kind of long, I tend to go for pretty descriptive names, so the queries are still long, but at least they're better, and the window function is in one place. So one question that comes up, and something we promised in the description of this webinar, is to answer the question, are window functions the only way? Like, what other ways could you do this? And the answer to that question, are they the only way, is most definitely not. One feature that ClickHouse has had for a long time is arrays. And so many of the folks on this call are probably familiar with them. It's useful to look at how you would actually, for example, do the cancellations ranked by week using arrays. And to be honest, when I created this sample, which does work, you can go ahead and cut and paste this. It should work on the data that we provided, assuming I got my cut and paste right. But this is a pretty complicated array, or query using arrays. The trick here with arrays is that you end up using two critical functions or features of arrays. One is what's called group array, which allows you to, what we're doing here basically is we group the data that we're reading. So we have a subquery basically, which does the initial calculations, and then to get our daily canceled, and then we're going to have to group it by week and collect all the values into arrays. We then do a trick here where we use array enumerate to get the indices of the arrays for the week, and then we sort those indices into reverse order using the number of canceled flights as the sorting key. And then we still got arrays here, and that's not what we want to see. We actually want to see a nice tabular result. We use what's called array join, where in the outside of this whole these two subqueries, we're actually now able to unroll these arrays for each of the columns back into normal tabular values, which are ordered by flight date. If you followed that description, you're pretty good at ClickHouse arrays. But what this illustrates is that, if you do an example like that, you start to understand why is it that people want to have window functions. One thing I will point out is that if you think about this, if you had multiple windows defined in your query, this would be really difficult to do with arrays. Arrays, basically, you're going to have to go ahead and do a group by, which down here, which amounts to the partition clause in your window, and then you're going to have to roll up all your columns. If you had multiple windows, how would you even do this? I think there are clearly queries with this where this would be very difficult or impossible to do. So anyway, that's an example of how to do it. There, you can still use arrays, and it's still worth checking them for small queries with small numbers of columns. Arrays can sometimes still be a very good approach. Okay, that gets us to the final part of this talk. It's not a terrifically long one. Let's just look at the roadmap. And Vitaliy, you had a number of features. Do you want to just talk through these a little bit? Because these were things that came out of your testing.
Yes, so we at Altinity performed the initial testing for the window functions, and some things are definitely not supported yet, as if you compare the functionality to Postgres or MySQL. And here are a few things that if once you try to take window function for a spin, something you will hit and you will find out. The first thing, range frame is very powerful. But right now there are limitations. The only data types that currently support is unsigned and signed integers, date, and date time. So if your column has any other type, right, including nullable, so nullable uint, nullable int of 32, for example, it will not work. You will get an error. So it's one of the limitations that are currently present. That's currently present in the implementation. The other thing, even though range frames are supporting date and date time, the truth is, working with them right now is not very convenient because there's no support for intervals. So you cannot say, for example, 300 days before this date or 30 days. There is a workaround, and you can specify it explicitly as a days, right, as an integer. But the problem is that computing ranges with dates and date times is not that straightforward. Especially because every year has a different number of days. Sometimes, so not every year has the same number of days. So you run into those issues. So without having interval clause, support for intervals, it's kind of hard right now to use range frames when your column type is date or date times. But if a workaround works for you, that's great. There's also right now currently no support for exclude clause, as well as there's no groups frames that are present, for example, in Postgres. Also, if you look in MySQL and Postgres, you will find that when they talk about window function, there's two standard window native function that are called lag, and the other one, sorry, should be lead. It's a typo. And you will not find them in ClickHouse. What you will find right now is there's a lagging frame window native function and leading frame window function. And the reason is because these lag and lead window functions, they're a little bit weird in the sense that they don't respect the frame boundaries. That's why ClickHouse, in their implementation, they have leading frame and lagging frame that are within, they respect the frame boundary. But if you want the standard behavior that you get for lead and frame, there's a workaround, and it's documented on ClickHouse Tech website. Also, you have to be aware that right now you cannot use combined window functions using expression. So you cannot just use them inside expression. It just will not work. There's also that you can't use range frame when you have a named window. As well as there's other limitations, but overall the functionality is pretty stable. And that's why soon I think it will be already not experimental, but production ready, at least for the cases that supports, it does support well. And when we did our testing, we compared it to functionality that's, for example, Postgres provides, as well as the validity of our results. And ClickHouse window function implementation performs well, and the results that you get are correct. And if you want to find out more information on window function, especially if you're not familiar, we would recommend that you go to the ClickHouse documentation and check out the documentation that there is. It's not a long, it's not big. It doesn't have any introductory material, but it has some limitation, what's supported, what's not supported in a concise format. You can also check out our blog article that we wrote as a result of testing we've done and the work we've done with window functions. And the blog article is called, Window Function Current State of the Art. You're also more than welcome for some details. Look at the software requirement specification that we have developed as part of our QA process, where we actually specify the behavior. It's something that we do in Altinity, and it's usually not done in other companies. That when we test something, we for ourselves first of all, specify the behavior. How software or a feature has to behave in certain cases. So you can go and find out some details, right? For example, how would it behave when, for example, Robert's showing like range frame when you have between unbounding, preceding, and with order by or without order by, right? And we have examples. So this kind of documentation we prepare internally for ourselves, and then we use when we develop tests. So it's very helpful if you're interested, especially not familiar. If you want to know the details, you can look at our spec. You're also more than welcome to check out Altinity knowledge base, and there's lots of examples, and including cumulative sums, for example. And you can more than welcome to check out a blog article done by Tiny Birds, and they talk about window function and provide some examples and use cases, some sample queries, and describe the basic functionality. You also, if you're not familiar with window function, you can look at the MySQL and Postgres documentation. I had to go through it. It's pretty good, but until you work with these functions, it's really hard to wrap your head around it. So that's why the picture that we had about the gory details of window function helps, especially people who are not familiar with window function, to get a conceptual understanding of their behavior.
Yeah,
Robert?
if I can dive in. So we'd also like to express special thanks. This has been a big community effort. Alexander Kuzmenkov, I mentioned him up front. He's the implementer of Windows Functions, still working on it. Unfortunately, he couldn't come to the talk today. Alexei Milovidov is the ClickHouse lead committer. He provided some helpful hints on, for example, on internal plumbing. And then, of course, the Altinity QA team did a really great job of testing this. I have to say it was mostly Vitaliy who's on this call, but the rest of the team helped by testing other stuff that needed to be done. We do a great deal of testing on ClickHouse. So anything, many of the features that you use are things that we've tested. And that's it. So I hope this has been useful. We're open to answer questions. If you have them, feel free to throw them out. See if you can stump us. In my case, it shouldn't be too hard. But we're happy to answer questions about this feature or related features in ClickHouse. So go ahead and type them into the answer box, and we'll answer them. While you're thinking about questions, if you have, if you do want to contact us, and talk about this in more depth, feel free to come over to the altinity.com website. You can also send email to info@altinity.com, but there's a contact us form, and we respond pretty quickly to that. ClickHouse code is in GitHub. Altinity.cloud, if you want to find out more about that, that's all the samples will run on that. And then finally, we're hiring. We're growing really quickly, have lots of customers, and if this is something you really like, if you didn't know this at the beginning of the call and you now fully understand Windows functions, maybe we should talk, because you obviously are good at this. So we welcome people who are interested in working full-time on ClickHouse. So with that, Vitaliy, I think we'll stick around here and see if we get some questions. Here's one. I'm going to let you have this. Can you maybe elaborate on the difference between the lag and the lag in frame window function? In what way are they not the same?
Thanks for the question. So like I mentioned, the difference from functional point of view, the difference is in the name, right? That's why in ClickHouse we have lag in frame, and that emphasizes that the lag function will respect the frame boundary. So in the standard SQL and Postgres, lag and lead will not have a frame concept, right? It would look at the whole partition window, right? So it will consider all the rows inside the window, right? And lag in frame will just consider the rows within that frame. And this corresponds for lead, right?
There was actually a question asking about a possible typo on slide 14. Did you see that one? It came up while you were talking.
Yes, I had lag and lag. Yeah, it should be lag and lead.
Okay. All right, great. Any other questions? We're happy to answer them. Otherwise, we're wish you well with window functions. Definitely, if you run into problems with them, feel free to log issues. There's still active work going on this, and this is something that we really want to help to make sure that it stabilizes as soon as possible. Okay. Hi, James. Looks like we've got friends. We've got a few friends here on the call. So welcome, everybody. It's great to see you. Oh, here's a question. Here's a great question. And this is from Jason. If window functions have to be executed sequentially after the usual data processing stages, does that mean using them will slow down my queries a lot or eat up a lot more RAM? And the answer to that, like a lot of things in ClickHouse, is it depends. If you have if you're running either complex window functions, like with multiple windows looking at things different ways, or you have very large, like a very large result set with your aggregates, yes, it will slow things down, and yes, it will use more resources. So what will, in particular right now, my understanding, I do not write the code for this, but my understanding is the usage of memory tends to be roughly linear with the result set size. So you're going to want to be careful about how many results you're passing back. So definitely, this is definitely something where it's a powerful feature, but there's a cost to computing these things, and you need to be careful. Vitaliy, we got a couple more questions popping up in the Q&A. Do you want to? So the first one is, so the lag in frame will honor the partition and will reset on each frame. Do I understand this correctly?
Let me see. So can I let me find the question again. So let me look at
It's
it.
open on the Q&A box.
So that would you lag in frame or calculate with array function in terms of performance? Well, when we talk, anytime we talk about performance, it's best to try it out, right? But given the the complexity that Robert showed with arrays, you have to see and measure it, right? But that would be my generic answer. That the lag in frame, give it a try. That's the best. It's a new feature, right? And especially if you haven't worked with window functions, give it a try, right? And do performance benchmarking, right? And let us know how it behaves, right? We haven't done much of performance testing. We did mostly functional testing of window function just to make sure that they behave correctly. Now that we know that they behave correctly, right? The next step will be to do performance testing. For example, on distributed tables, right? And see how much memory it actually uses.
I think you can expect a blog article from us in the near future about this, and it will probably be. There's also, I didn't mention this, but there are other ClickHouse functions. Like if you're doing lag and lead, there's also what's called a neighbor function that you can use. So ClickHouse tends to have specialized functions that answer some of these questions. So we have a task in front of us to go benchmark all of that. And yeah. So I just want to make sure we've got this final question. Highlighted that the lag in frame will honor the partition and reset on each frame. And can you just confirm that, Vitaliy?
Could you please repeat the question? I was just, answering about slide 14, which I took a look at slide 14, and it does seem to be correct, right? I think the default, range between unbounded, preceding, and current row is correct. And I think the question was, is it supposed to be right unbounded? And the answer is no, it's not right unbounded. That's the trick. The bound is a current row, but because all the rows of the current rows are the peers of the current row. That's why it seems like it's right unbounded. If you would add the order by clause, you would not see that behavior. And that's the trick part to understand the peers of the current row and what it actually means.
Thank you. That's a great explanation. So, and I think the question is that Felicity was answering is correct, that lag in frame will honor the partition and reset on each frame. So that was your point.
That's correct.
Yeah, great. Well, hey, these are excellent questions. We really appreciate them. If you have more questions, please feel free to contact us directly. There's also a lot of community interest in this. You can ask on Telegram. Our support folks who, there's a couple of them who've dealt quite a bit with Windows functions. They're available there. And you can also talk to us directly at Altinity. So with that, I'd like to thank everyone in the audience who attended. It's a pleasure to be able to present this information. We're glad that it's useful. And I'd also like to thank Vitaliy, my colleague, for helping so much with this talk and doing all the testing and other work that was necessary for us to validate and understand and fully validate Windows functions. So thanks, Vitaliy.
Thanks, everyone. Thank you, Robert.
Have a great day. Talk to you soon.